Question number 18, CY 2022, and the question is, the resonance Raman stretching frequency of the coordinated dioxygen in oxyhemoglobin and oxyhemocyanin appears respectively at option A 1136 and 744, option B 1550 and 744, option C 744 and 1136, at last option D 744 and 1550. You have to choose the correct answer among these options. Now coming to the answer. So first we have to draw the structures of these two compounds, that is oxyhemoglobin and oxyhemocyanin. First start with oxyhemoglobin. This compound will form when oxygen binds with the hemoglobin of the blood. Now hemoglobin, you all know, is kind of porphyrin ring, and inside the porphyrin ring iron 2 plus ion will be there. So the structure will be this is the first iron system adjoined by the nitrogen. Now I have to draw the whole porphyrin ring. So this is the inner porphyrin system. Now the adjacent substituent with the porphyrin. This is an ethylene, this is a methyl. Okay. Okay. This is a basic porphyrin system of the hemoglobin. Now they will attach with oxygen. So this is the structure of oxyhemoglobin. Now coming to the structure of oxyhemocyanin. It is a copper complex where one oxygen molecule is binded with two copper 2 plus atom. Okay. This is the copper 2 systems. Now one oxygen molecule will come and bind with these two copper 2 center. Now you can So this is the structure of oxyhemocyanin. Now we have to look into the differences of these two structures. The actual difference we have to check. There is a linkage of oxygen with the metal center. In this case, the oxygen molecule is binding with the iron 2 center with one of its oxygen center. But in case of oxyhemocyanin, oxygen molecule is binding with the copper 2 center with both of its oxygen center. Thus, in case of oxyhemoglobin, the oxygen molecule is present as O2 minus system, and in case of oxyhemocyanin, the oxygen molecule is present as O2 2 minus system. You can see if in the picture that there is a minus charge is one of the oxygen atom that is binded to the iron 2 plus of the hemoglobin in case of oxyhemoglobin, and here both the oxygen atom of the oxygen molecule bears minus charge after being conjugated with the copper 2 plus cations of the hemocyanin moiety to form the oxyhemocyanin. So there is a difference in the charge of the binded oxygen atom. Just we have to find out the bond order and corresponding the bond length, then easily we can say which oxygen system has higher new stretching frequency value and which have lower new stretching frequency value. Now coming to the next part, oxygen molecule, the configuration we can write in terms of MOT as molecular orbital theory. The configuration of O2 can be represented as 1 sigma G 1s 2 1 sigma U star 1s 2 sigma G 2 2s 2 sigma star 2s 3 sigma G 2px 2 pi U 4 2pz and pi star 2g 2py 2pz. This molecular orbital will form by the combination of atomic orbitals of the oxygen atoms. So this is the MOT configuration of oxygen molecule. Thus, from this configuration we can easily find out the bond order. Bond order of O2 will be, now we have to count the binding electrons first. Now what are the binding electrons? All the pi U and sigma G electrons are the binding electrons. So here first these 4 pi U electrons, then this 3 sigma G 2 electron, this 2 sigma G 2 electron, and then 1 sigma G 2 electron. So the total number is 10. Now we have to count out the antibonding electrons. So this is the pi star 2 electron, sigma star 2 electron, and again one more sigma star 2 electron. This is 6 by 2. So this value is, so bond order of oxygen is, now easily we can find out the bond order of O2 minus and O2 2 minus system. The configuration of O2 minus is very much similar with that of the configuration of oxygen molecule. Only one electron more in the pi star G orbital. Thus configuration of O2 minus is similarly Now 1 electron more in the pi star orbital. Similarly, we can also represent the configuration of O2 2 minus, 1 electron more than the O2 minus system. One electron more than the O2 minus system and 2 electron more than the O2 system. Easily from this configuration, by the similar manner, we can find out the bond order of O2 minus and O2 2 minus. Thus, is 10 minus one more electron in the antibonding orbital, that is 3 by 2, that is 1.5, and bond order of O2 2 minus is 10 minus 8 by 2, that is 2 by 2, that is 1. Now bond order increasing order. So if you go down, bond order increase, first O2 2 minus, then O2 minus, then O2. Thus, with the increase of bond order, the bond length will decrease. Bond length decreasing order. With the decrease of bond length, the stretching frequency also increase. Thus, easily we can say that with increasing bond order, bond length decreases and followed by new stretching frequency will increase, because the stretching frequency will have a proportional relationship with the bond order and inversely proportional relationship with the bond length. Now if you come, this O2 2 minus is hemocyanin. This O2 minus is hemoglobin. Thus, easily we can say the new stretching frequency, the new oxygen-oxygen stretching frequency of the oxygen molecule in oxyhemoglobin is higher than the new oxygen-oxygen stretching frequency of the oxygen molecule in oxyhemocyanin. Now coming to the options, 4 options are given. Option A 1136744, option B 1550744, option C 7441136, option D 7441550. So last 2 options we can omit, because easily you can see the first compound is hemoglobin and second compound is hemocyanin. In case of hemocyanin, the stretching frequency value has to be higher than the stretching frequency of oxygen molecule in case of hemocyanin. After omitting the last 2 options, coming to the first 2 options, that is A and B. Now the new oxygen-oxygen of O2 molecule is about 1580 centimeter inverse. This is quietly matching with the value of 1550. So the option B also we can omit, because this value corresponds to O2. Now only one option remains, that is option A, and that is your answer, correct answer. So your correct answer is option A, that is the new oxygen-oxygen stretching frequency of the oxygen molecule in hemoglobin is 1136, and the new oxygen-oxygen stretching frequency of the oxygen molecule in hemocyanin is 744. You can easily find the reference in the lectures on life with oxygen, general discussions, oxygen carrying proteins, hemocyanin and hemoethrin, hemoglobin and myoglobin by Professor S.P. Roth, Department of Chemistry, IIT Kanpur. Thank you very much.